First off, I went ahead and turned on Respondus and Lockdown Browser for the test. I just want to see what happens for all my classes this summer. How many of y'all have never used Respondus before? Okay, that's when you go to your tests. It's only for your tests. You click on it. It's going to say on the bottom you need to have Lockdown Browser installed. So you have to go to download it and install it. What it does, all it does was when you're on the test, it'll tell you, okay, you have 100 minutes to finish these 9 questions, all right, 10, however many questions you have. And it's going to lock down your browser so you can't get off that page of the test. You can have access, if you go to the bottom, you can't have access to the calculator if it's provided. All right. So the reason I'm doing that is because a lot of students make hundreds in calculus 1, 2, and 3 without any mistakes. And in less time it takes to read the test. I couldn't even do that when I took calculus 1, 2, 3. So I need to see what's causing all. I know it's causing it. I just have to try to put an end to it. But again, you still have as many tries as you want on it. So don't let that worry you one bit. I need to catch the students who are cheating on these things and get them kicked out. Yes. Because the AI apps that they use will show you step by step what you're supposed to do, and you can copy it. It's the mouse and mousetrap thing. The apps are there. You could take a picture of the question, or you could type in the question and hit enter. It'll work out step by step by step by step by step, and then give you the final answer. But if it's asking, it'll ask you if you put in there if you want limits or not. So yeah, you're right. But yeah, you're right. If in chapter 2, if you're using derivatives or you're using stuff we're going to do in calculus 3, then that's a good sign. But there are other apps in there that'll tell you. You can just say solve this equation using limits, and it'll tell you everything. Because again, AI only goes and pretty much it reads the textbook for you, and it doesn't work for you. And that doesn't help you any. If I was an employer, I wouldn't want anybody who got through math using AI because they don't know enough afterwards to be worth anything. And that's why also at the end of the class I say, if you want a recommendation letter for me for whatever reason down the line, before I give it to you, I will ask you 3 questions, and you'll do 3 questions in front of me over the classes that you've had with me. If you can't even start to answer them, that'll be under your discussion for a recommendation letter. But if you could do it and you could logically walk me through it, then yes, I'll be more than happy to give you a recommendation. Because I've had people who've done nothing but online courses with me, and they claim to make A's and everything. I look at their work, and they finish 10 questions in less than 10 minutes. I wish I would look at that sooner. So again, if you do the work and you're honest about it, then great. You still have your notes next to you. It's open notes still. It's just that you can't use artificial intelligence, and it records you what you're doing. You have to have your camera on. You have to have everything. So in other words, if you're taking the test and you're doing this, you're using your cell phone for something to try to get the answer, that's automatically cheating. It's a 0 for that test. In other words, don't answer any text messages or anything during a test. It's closed everything other than your notes. All right, so and I'll send a remind message out for everybody about that as well. So when you go in there, it'll give you this question. This thing here says you have to have Respondus turned on. So go down here, download it, and install it, and it'll tell you all the percentage. And then once you do that, then you can start, and it'll tell you. So we have 9 questions. You have 100 minutes. It shouldn't take you more time than that, and it will record you and it'll send me the recording. Any questions? Yes.
I think my computer. I have like
I have a PC. Then you may have to get a camera. Because you need it anyway to, or you can check it out from the school. And they should have responders put on there already. But you can get those, yeah, those little cameras that plug into the side. They don't cost more than 15, $20 now. And besides, you'll need that if you ever get a job and you need to talk to your boss. They're never going to take a blank screen. They'll say, I want to see who I'm talking to. So you'll need it eventually. So I just want to tell you that right off the bat. All right. Any questions? So what we did yesterday?
I had a question.
Yes.
It was over the example 8 on 3.3, the monomial one with the x to the fourth power.
Okay. So what was that example?
It was y equals
Oh
parentheses.
yeah, I said yeah. It had the monomial on the bottom.
Yes, sir. So did you do it a shorter way because it was a monomial, or could you do that for other types of problems?
Well, because it was a monomial. If you had a binomial, a trinomial, or nth nomial on the bottom, then you'd have to do the long way. You have to use the quotient rule.
Okay.
But because the denominator was a monomial, we could divide each one of them separately and do the sum and difference rules on each one separately.
Okay. Okay.
It takes a lot of stress off the work doing that.
Okay. Okay. And then
But
another
yes.
question was on the homework, and this might be a chain rule question, but it's on the 3.3. It was y equals 5e to the negative x plus e 4x.
Let me see here. All right, I'll get to this one. So homework question.
Yes, sir.
What was it again?
It was y equals 5e to the negative x power plus e to the 4x power.
And I ask you to find a first derivative.
Yes, sir.
So the first derivative, what will be the derivative of the first term? What would be the derivative of 5e to the negative x? Since 5 is a constant, it stays there. The derivative of e to the x, or e to anything, is e to anything times the derivative of the exponent. The derivative of negative x would be what? Hello?
It would be 1 over x.
Nope. The derivative of just, if y equals negative x, what's the derivative of that?
Negative 1.
Negative 1. So that one, then it multiplied by negative 1.
Okay.
So we have the 5, which is a constant, the e times the derivative of the exponent. Plus, same thing here. You have the e times the derivative of the exponent, which is what?
4.
So your answer would be negative 5e to the negative x plus 4e to the 4x. There's your first derivative.
Okay, thank you.
Right? Any more questions? All right. Section 4. We're going to look at derivatives as a rate of change. Not only restricted to time, but anything that's occurring, as long as the quantities are changing, we can find the derivative of it. We're looking for a rate of change of that. So I put this up originally to discuss where we started off and where we've been to. What is this formula called? It's a difference quotient, but it was also the average rate of change. Because we're taking the two numbers and we take the average of that. This we just defined as being a what? This is difference quotient, but it now takes into account a limit. What does h represent? Right, the difference between the x values. So as h goes to 0, we're now going from 2 points to only 1 point. So this is now instantaneous rate of change. So it's going from average to instantaneous rate of change. And also, so we know that from our discussions earlier, but what else does this equation equal? It gives us a slope, but what else does it equal? The derivative. So the derivative is the instantaneous rate of change at any given value x. Which is the definition. So the instantaneous rate of change of our function with respect to our variable t, our x in this case, is the derivative of our function at some value x. As h goes to 0 of our difference quotient. If it exists. So you see the big change we just took from chapter 2 to chapter 3. In order to find the instantaneous rate of change, we had to physically do the secant line, the slope of the secant lines, all getting closer and closer and closer and closer and closer and closer. And unfortunately, we could never get to those points because we can't divide by 0. So now we don't have to worry about that. We just take the derivative and we're done, which is much, much, much easier way to do things. Let's look at an example. Example 1. The area A of a circle is related to what? What is the area of a circle related to? What is the moving vector? Diameter. Given by this equation. Area equals pi diameter squared over 4. So my question is this. How fast does the area change with respect to its diameter when the diameter is 10 meters? So we have area equals pi over 4 d squared when the diameter is 10 meters. How fast? What is the rate of change? Are we looking at an instantaneous or an average rate? Well, we only have 1 point, so it has to be instantaneous. It's not asking between these 2 points. It's asking for this. So it's instantaneous. What formula do we do for instantaneous rate of change? Which is also called the what? The derivative. So we can find the derivative of this. Pi over 4 is the constant multiple. Pi is a constant, 4 is a constant, so nothing changes there. The only thing that changes is the diameter. So what's the derivative of with respect to diameter? So it's 2d. So that becomes the 2 and the 4 cancel. So it's pi d over 2. That's the instantaneous rate of change. When d equals 10, we get the average rate of the instantaneous rate of change is pi times 10 over 2, which equals to 5 pi. 5 pi meters. Meters what? Because it's the rate of change. What's changing? Per meter. Which is the meter, it becomes meter. So it becomes 5 pi meters. Meters square per becomes meters. So whenever you use instantaneous, yes, you don't have to use the limit, the difference quotient anymore. You use the first derivative, and we're done. Motion along a line. This is a moving problem. So we're looking at 4 things. The displacement, the velocity, the speed, and the acceleration. But once we have acceleration, we can go one step further and talk about a jerk. How are they related? What is displacement? Moving from point A to point B. We tend to give this, remember, since we're moving along a line, we have with respect to time. So that is our function we're dealing with. It's S of t. It's our displacement. How far something's moving from point A to point B. What is velocity? Okay, but we haven't talked about speed. So what is speed? You can't use it unless it's been defined. Velocity is the change of displacement over the change of time, which is the first derivative of our displacement. So displacement is moving from point A to point B. Velocity is that change of displacement from point A to point B over time. What is speed? So This one again, these are all sorts of different ways we can write these things. The derivative of s with respect to t. So what is speed? You're right. Velocity, well, it doesn't have a direction because it doesn't tell us when you're going in your car and you're driving, it doesn't your odometer doesn't tell you you're going 20 miles an hour east. So it's just going 20 miles an hour. We assign positive and negative in our distances, directions of going. But speed is simply the absolute value of velocity. Can you have a negative velocity? We can go backwards. It's relative too. But again, your car doesn't tell you you're going negative. If you ever look at your speedometer when you're going backwards, what does it do? It still goes in the positive direction. Because now your car is interested in your speed. The speed is the absolute value of velocity, which is the absolute value of s prime of t, which is the absolute value of ds dt. So we have displacement. The first derivative of that is your velocity. So what do you think acceleration is? Acceleration is a change of velocity. So acceleration is the first derivative of your velocity. Which means it's what? If it's the first derivative of velocity, and velocity is the first derivative of displacement, that means acceleration is the second derivative of displacement. It's the change of position over change of position over time. And jerk is simply the change of acceleration, which means it's the second derivative of your velocity, which means it's the third derivative of your displacement. Never thought about that way, did you? No, it's just so this is how everything's related. So let's define velocity. We have two different types of velocity. Average velocity and instantaneous velocity. So average velocity is simply the change. Oh, I'm going to put S there. It's a change of displacement over the change of time. Instantaneous velocity is the limit as delta t goes to 0 of that displacement, the change of displacement. again, so you see the difference between average and instantaneous. Average doesn't have the limit, instantaneous has a limit. And the definition of speed is the absolute value of velocity. So example 2. Did you guys, did everybody get a copy of this packet? Did everybody get a copy of this packet? This packet? Yeah, it was in the back of the room for a long time. Let me see. I'll put it in here. Yeah, so right now, example 2 is going to deal with this. The velocity graph. So what does this part mean? If the graph is going up, what does that tell me about the velocity? You should, if you don't have the packet, I mean, you should have the packet. Look at it. So in section 3, chapter 3, section 4. So if it's going up, what does that tell me is happening? So the velocity is positive. What happens if it's horizontal? Velocity is constant. So you are increasing and then it's just going, you're coasting at that speed. What about if it's going down? You're decelerating. So your velocity is now negative. It's slowing down. At this point, what happens at this point here? Is that 5 or at 3? What happens at 3? It stopped. It's 0. It's not moving at all because here it's coasting. Here at that, when it crosses the axis, it stopped because the velocity is 0. So there's no displacement movement. Then it does what? What happens? What does this mean down here? Actually, other ways. It's negative, so it's going backwards. So you're accelerating backwards. And then what this means is you're decelerating backwards. Eventually you stop. You stay stopped until you move again. This is how you interpret the velocity graphs. So if it's going up, you're increasing, going down, you're decreasing velocity. And if it's below the x-axis, you're going backwards. So that's what it's telling you. Right? Look at the example. Yeah, I didn't put the definitions of acceleration and jerk because it's just that acceleration is the first derivative of velocity, and the jerk is the first derivative of acceleration. All right, this one. Here's our figure. A ball is dropped. That's 0, 5, 10, 15, 20, 25, 30, 35, 40, and 45. So this is at t equals 0. At t equals 1, this is your displacement in meters. At 2 seconds is at 20. And at 3 seconds it's at 45. According to this now, we're looking at shows a free falling body from rest. The question, if you're looking at it, it says shows a free fall of a heavy ball bearing released from rest. Does it need to say that it's heavy? If it was a BB as opposed to a bowling ball, would it fall any different? Would the time be any different? No. The only force would act upon that would change it would be air resistance. And at this short time, it's negligible. So it was redundant with them saying it's a heavy ball bearing. So A, how many meters does it fall in 3 seconds? What is the velocity and acceleration? At t equals 3. Okay, since it's a free falling object, the position function is given by this. Or I could put A here. In stable condition. It's a free falling. So what does V sub 0 represent? Oh, this is T. What does V sub 0 represent? Velocity where? This is initial velocity because it's sub 0. What is H sub 0? Initial position, right? And A represents acceleration of gravity. There's the only force acting part is gravity. It is acceleration, yes. So we're going to have to use the function, since we're dealing with meters per second, we have to use 9.8 meters per second squared. That's metric. If we use the SAE, we have to use something like 16 feet per second squared. So that's the big difference. And it's 1/2. So it's 1/2 gravity times time squared plus 0 times time plus 0, your initial position. So the formula we're going to use for a free falling object is that. So our position function, what's half of 9.8? If it was 10, it'd be what? It'd be 5, right? But we lose 2 points. If we wanted to be precise using this picture, we would make it a negative because it's falling down. But all it's asking for is just a position. It wanted how far does it travel in 3 seconds? So when t is 3, we get 4.9 times 9. 9 times 9 is 81. 4 is 36. 36 plus 4 is 44.1 meters. So that's how many meters it fell in the first 3 seconds. Now B, this is A. B is asking what is the velocity? So we know the formula that we have to deal with. 4.9 t squared. So what's velocity? The first derivative, so velocity is the first derivative of our displacement, which would make it 4.9 times 2t, which would make it 9.8t. So we want the velocity at 3 seconds. So 9.8 times 3. 3 times 8 is 24. 3 times 9 is 27 plus 2 is 29.4 meters per second. Isn't this a lot easier than using the limit and the difference quotient? A lot. It also wants the acceleration at time 3. So the acceleration is the first derivative of velocity. So the formula for velocity was 9.8t. What's the derivative of 9.8t? 9.8 meters per second squared. Because it's acceleration after the first 3 seconds. What does that tell us? What does this one tell us? It tells us what Galileo proved. Everything falls at the same rate. The velocity is 9.8 t, but the acceleration is 9.8 meters per second squared. Everything falls at the same rate. It doesn't matter how big or how small it is. So this is what gave us the acceleration. Any questions so far? You're staring at it like it's going to jump out at you. What part didn't you get?
Understood everything. It was just like it seemed like a lot, but I feel like using the limit would have been way harder. But I understand.
Well, yeah. Only thing you really need, you need to know what your initial position function is. Because once we know S of t is 4.9 t squared, then the velocity is the first derivative of that, which is 9.8 t. The acceleration is the first derivative of velocity, which is 9.8. Example 4. A dynamite blast. Rock is blown straight up. With a velocity of 160 feet per second. It reaches a height of S of t equals 160 t minus 16 t squared feet after t seconds. And I'll talk about this formula in a second. Find A. How high does it go? What are the velocity and speed of the rock when it is 256 feet above the ground? On the way up and down. What is the acceleration? Of the rock at any time t? And when does the rock hit the ground again? So before we do these questions, let's look at the position function. Or actually, instead of H, I'll put S. Sub-zero. Or you can put, instead of that, you can put S at T sub 0. For acceleration, since we're dealing with a object that's falling and just the force acting upon it is gravity, V sub 0 is the initial velocity at time equals 0. And S of T0 is the initial position at T equals 0. Because if you look at your pictures, the rock was here. It said the rock was blown straight up. So it blew up and it went all the way up and it came all the way back down. So at the initial position, what was its height? It was at 0. Since this is very important, since we're using feet as a unit of measurement, what's gravity then? Actually, gravity is actually 32 feet. Because remember, 9.8 meters per second squared was gravity for metric. Gravity for our system of measurement, which is feet, inches, yards, crap like that. So basically, pretty much it's multiply this by 3.2. It's going to give you 32 feet per second squared. That's gravity. But for gravity, it has to be 1/2 gravity for our acceleration. So we have 1/2 gravity at whatever time squared we have, plus our initial velocity at time t, plus our initial position at time 0. So since we're doing SAE, we have 32 feet per second, t squared. The initial velocity at explosion was 160 feet per second t, and our initial height was 0. So far, so good. Since it blew up, our initial velocity was going up. So what does gravity have to be then? It's got to be negative because it's coming down. So what's half of 32? So it's negative 16 t squared plus 160 t. That's our position function. That's what it gave us earlier. It didn't have to give us the formula. All it had to do is give us this information and we were done. We could have figured this out ourselves. So let's figure out what A says. How high does it go? So let's figure this out. How do we figure out how high it goes? It wants to know this information here, right? So what kind of graph is it? What kind of function is this? It's quadratic. So what kind of graph does it have? It has parabolic, which means the top of it is called the what? The vertex. And the vertex is made up of an x component and a y component. It's a point, it's a location. Where in our case, the x component is time, and the y component is our position function. Now comes the question. How do we figure out? So we have to figure out the time. What's the formula we know from algebra to find the time of our function? No. Well, we could. So you're saying we can find the velocity, right? If you said delta y, delta x, that's velocity. That's the change of position over change of time, which is a derivative. Okay. We could do it algebraically or we do it calculus. What is the velocity? What do we know happens at this point? The velocity at this point, this stage is what? So the velocity is equal to 0. And what we can do, we can find the velocity and find out what is the t when it equals 0. That's one way we can do it. Another way we can do it is algebraically. Negative b over 2a, since we have the function. Hopefully they'll both give us the same answer. Let's go and figure this out. So let's find the velocity. How do we find the velocity? It's the first derivative of our position function. So if our position function is negative 16t squared plus 160t, what's our first derivative of that? Negative 32t plus 160. Set that equal to 0. Let's solve for time. So we have, move the 32. So we have 32t equals 160. $160 divided by 32 is 5. No. What I did was I moved this guy over there. It would have been, but I changed the signs. Oh yeah, I forgot to say that. I moved it and I flipped it around. Okay, let's try the same question with the algebra portion of it. the time component is negative b over 2a. So in our function, b is 160. So it's negative 160 divided by 2 times a, which is negative 16. They're both negative, they cancel. So 160, 2 times 16 is 32. Same question. So we could have done either way. So we know it takes 5 seconds to reach the highest point. So the highest point occurs at 5 seconds. So we have negative 16 times 5 squared plus 160 times 5. Negative 16 times 25 and 160 times 5. I'll do this in a second. 25 times 16, 30, 12 is 15, 5 and 2. So it's negative 400 plus 0, 30, 800, which is a 400 foot. So the highest it goes is 400 feet straight up after 5 seconds. Any question about that? So we can either use calculus, take the derivative, set it equal to 0, or use algebra, which we know the same formula. We could just do that. Question B, what are the velocity and speed of the rock when it reaches 256 feet? Why does it worry about up and down? Because if we look at remember, the highest it goes is 400 feet. So 256 feet, it has to be going up and it has to be going down to reach that same height. And are the velocities going to be the same? No, because this one started off at 160 feet per second and is shot straight up. So it's slowly decreasing speed. This one starts from a free fall and drops. So it's 2 different actions on it. So we may have 2 different velocities. So it's saying, what are the velocity and speed? At S of t equals 256 feet. Up and down. So what formula we're going to use here? What's that? Yes. Yes, physics is mathematics in motion. So that's why if I can meet with a physics instructor and borrow some of their toys, we could do that in this class and predict everything already, which is the same thing you guys are doing in your physics labs. Thermal expansion, constriction, all that sort of stuff. So what formula are we going to look at? What do we have to start off with? Oh, we know our S. Our S formula is negative 16 t squared plus 160 t. Because we're looking at it, when does that equal 256? What do we have to know first? In order to draw a picture, our picture going up and coming back down at 256, we have to know at what time do these occur. Once we know the times, then we can plug it into the formula and then come up with an answer. So we set this equal to 0. Well, yeah. Negative 16t squared plus 160t minus 256. So I moved it over. Since I have a negative coefficient, I just change all the signs. We could just go ahead and just plug this straight into the quadratic formula and work it out, but the numbers are going to be pretty big. Can we simplify it? They all have a what in common? Okay, this one has 16. Does 16 go in this one? How many times? If you studied engineering, no, you don't need that. Let's look at 256. We have 2 goes in there 128 times. 2 goes in there 64 times. 2 goes in there 32 times. 2 goes in there 16. 2, 8. 2, 4. 2, 2. 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 to the 8th power. Well, 16 is 2 to the what? 2 to the 4th. So we have 2 to the 4th out. So we're left with 2 to the 4th, which is 16. If we got rid of 16, which is 4 of these, we have 4 left. You don't need a calculator for this stuff. Divide both sides by 16, that disappears. So our function we're looking at is that. So that's factor. Where does t squared come from? T times t. What do we know about the signs? Look at the second sign. It's a plus. That tells us they're both the same. They both have to be the first sign. They're both negatives. What times what is 16? When you add them, you get 10. So it's 8 and 2. So the time is at 2 seconds and at 8 seconds. 2 seconds, it's going up. 8 seconds, it's going down. All right. So the velocity. We're looking for the velocity. So we start off, we have to find the first derivative of our position function, which makes it negative 32t plus 160. So v at 2 is negative 32 times 2 plus 160. And then v at 8, which is negative 32 times 8 plus 160. Negative 64 plus 160. Negative 256 plus 160. So this one is 96. This one is negative 96. So this one's going up. This one's going down. So what's the speed? That's velocity. Absolute values, right? So the speed is absolute value of v at 2 is absolute value of 96, which is 96 feet per second, and absolute value of v at 8, which is absolute value of 96 feet per second. Those are the speeds. Now, is it going to be the same if we went to 300 feet or 100 feet? Chances are no, because again, it's the initial velocity of launching it up at 160 feet per second, as opposed to coming down, starting from rest, from 0, going down to us. What's the fastest it can fall? What's terminal velocity? $120 miles per hour, approximately. That's terminal velocity. So, on the way up, it's decreasing. On the way down, it's increasing until it gets to 120 miles an hour. So, if you think about it, going up, at the initial point, what was the velocity there going up? 160. Coming down, what's the fastest it can come down? 120. So it won't be symmetric on both sides. All right. So the next question it asked was, what is the acceleration at any time t? And then when does rocket hit the ground? So c is the acceleration, and then d is when does it land? So for c, what is the acceleration? What's the formula for acceleration? Right, so we have our s factor, which is negative 16t squared plus 160t. So the velocity is negative 32t plus 160. So, and the acceleration is the first derivative of velocity, which makes it negative 32 feet per second squared. So what does that tell us? It's constant. So it's terminal velocity, terminal acceleration. It can't go any faster. So any time along the curve, acceleration is the same. At any time t. So it lands after how many seconds? So how do we figure this one out? So when it lands, what do we know at that point? What's that?
What?
Y equals 0. And y is the position function. So we have negative 16t squared plus 160t. Set that equal to 0. We can factor out a negative 16t, which will give us a t minus 10. So this, set those both equal to 0. This is the launch, and this is the land. So it'll land after 10 seconds. Pretty easy. Yeah, you guys will see a bunch of these in physics. It's all if they throw it to me. I'm in a major demand for Cal 1, so it's if they need me for Cal 2. Normally I do in the fall semester. I'm pretty sure it's the fall semester, but yeah, I do. No, I do the spring semester. I do Cal 2. But no, I'll see. I'll ask them. All right, so that's physics. That's motion. That's things moving on some direction. What about when it comes to economics? The basic law of economics is profit. You try to make money. What defines profit? So what's the formula for it? Revenue minus expenses. Income minus cost. Because expenses is a pretty big, if you think about it. Revenue, what's revenue? What defines revenue? Money coming in, but money coming in after what? You spend your taxes and things, but those are your expenses. Your rent, your insurance, your electricity, your water. So that is what differentiates your profit. So they each have to do with respect to not necessarily time, although your expenses are time, because those, if you borrow money from a bank, it's all based on time. But in business, like Nike, they make their money if they do what? Sell items. So this is not really time based, it's now sales based, item based. So the profit is pretty much determined by revenue minus cost. amount of dollars to stay open. That to do business. Can you have a change in cost? Yeah. A lot of factors can change cost. So any change in cost is called the marginal cost of production. The marginal cost of production is the rate of change of cost with respect to the level of production. So it's dc over dx. That's marginal cost. It's the derivative. So it's the derivative of the cost function. And there you have a whole field of economics is determining the revenue and cost and profit functions. They're based on so many different variables. Very, very complex. Revenue. Amount of dollars coming in. So any change in revenue is called, what do you think it's called? The marginal revenue. The rate of change of revenue with respect to the level of sales. dr over dx. This is a pretty example. What determines if you're going to make money or not? What about sales? Compared to? Yeah. You'll make money. You're right. It's how much money you'll make is how many items you sold, but it all depends on what it costs to produce all those items. This is a very popular graph. At this point, that's your break even. Because your revenue, your sales are pretty low, right, when you first begin. And what happens, you have a large stockpile of items, you're losing money. So eventually sales pick up. So the cost of producing them goes down because you're producing a lot more items and your income increases. This is also similar to what's the profit loss statement. The more money you make, the less money you lose, you'll have a break even point. Let's work on an example. Example 5. Suppose it costs x cubed minus 6x squared plus 12x dollars to produce X items, or radiators. When 8 to 30 radiators are produced. Okay, this is an off the topic, but why is this as important? Why is that important? It costs this much when 8 to 30 are produced. Will it change if I produce less or if I produce more? It will. If I produce less, it costs more because I have all this other the material inventory still in hand. So yeah, that's why it changes on how many you produce. That's the target what companies try to maximize. Think of fast food. How many of y'all ever eat McDonald's or Dairy Queen or anything like that? Any fast food. What matters there is how many. It's rush hour. How many hamburgers? How much fries? How much do we pre-produce? Because your objective is to try to get the customers out fast as you can. So you have to have stuff ready to give them to get them out. But think about it. If you cook your fries too soon and somebody comes in an hour later, those fries are cold. They don't want them. Give me another pair. So you just lost that batch of fries income. So all this stuff, your production and when you do it, how fast you produce it is very important when it comes to business. So what else we have to produce? And R of X is equal to X cubed minus 3X squared plus 12X dollars from selling X radiators. Your shop currently produces 10 radiators. Currently, we produce 10 radiators a day. How much extra will it cost produce? How much more will it cost to produce? How much extra will it cost to produce one more radiator a day? And then what is the estimated increase in revenue? then profit for selling 11 radiators a day. Okay. So what do we have to find? What are we looking for? We have the cost function. We have the revenue function. We know we currently produce 10 radiators a day. What are we looking for now? How much will it cost to increase the production to 11 radiators, one more extra? And then if we do produce those, we know how much it'll cost. What is the increase in revenue and profit for that one extra radiator? So how do we go out and figure out? What's the first thing we have to figure out? We figure out what our present cost is. What is our current cost and our marginal cost? Because we're changing from 10 to 11. So what's the first thing we look at is the marginal cost of increasing. So we have C of x is equal to x cubed minus 6x squared plus 15x. So the marginal cost is the first derivative, which becomes 3x squared minus 12x plus 15. So that's the change. Currently, we have how many? 10. So we put anywhere we see an x, we put a 10. So we have 3 times 100 minus 120. So it's 300 minus 120 plus 15. 300 minus 120 is 180 plus 15 is 195. So the additional cost will be about $195 to produce one more. So it's going to cost us that. So what's our marginal revenue? The estimated revenue will be, so if we get marginal, R of x is x cubed minus 3x squared plus 12x. So R prime is equal to 3x squared minus 6x plus 12. At 10, we have 3 times 10 squared minus 6 times 10 plus 12. So it's 3 times 100 minus 60. So 300 minus 60 plus 12. 240 plus 12 is 252. So our increase sales will be 252 minus 195 equals $57. That's the difference between the sales and revenue and sales. So is it worth it? Yeah, it's only one more each day, so they'll increase that. Pretty straightforward. So whenever you look at that, you look at what is the change? We call it marginal change. We're saying what is the change from where we are now to where we want to go? Okay, that's it for that section. All right. And that does it for today. Remember also next week.